This is a continuation of the Chapter 10 review, starting with problem 25. In problem 25, we have two inscribed angles, and it appears that angle KJL and KLM are both intercepting the same arc. Therefore, by the inscribed angles in a circle theorem, these inscribed angles have to be congruent. That means that 14D equals 70. And since we're looking for the value of the variables, we can say that 14D equals 70. Divide by 14, D equals 5. All right, now for problem 26. Let's go ahead and write 25 here just for kicks. So for 26, what we have is we have an inscribed triangle. Now when I look at this, the first thing that jumps out at me is this inscribed angle is intercepting this big arc. And you can see that NQ is a diameter. So therefore, if this is a diameter, this arc has to be a semicircle. We know the measure of a semicircle is 180 degrees. Well, since an inscribed angle is 1/2 its intercepted arc, we know that this angle has to be 1/2 180, which is 90 degrees, which makes this a right angle. And that makes triangle PNQ a right triangle. So we can find y by stating that 3y equals 90. We divide by 3, y equals 30. Now let's move on to z. If this is a 90-degree angle and this is a right triangle, then you know these acute angles have to be complementary because the sum of the measures of the interior angles of a triangle is 180 degrees. Therefore, 50 plus 4z has to equal 90 degrees because these have to be complementary angles. Let's go ahead and write that. 50 plus 4z equals 90. Now if we subtract 50 from both sides, 4z equals 40. Divide by 4, z equals 10. That finishes problem 26. Let's move on to problem 27. In problem 27, we're asked to find the value of the variables. Now they've thrown a lot of information in here, and it looks like it's kind of complicated, but fear not, because the more information they give us, the more information we have to work with. So don't look at it as a frightful thing, look at it as a helpful thing. Here we have inscribed angle M, with m degrees here, is intercepting arc VT. Well, angle S, VST, is also intercepting arc VT. That means this angle and this angle have to be the same measure. That tells us for 27 that M has to equal 44 degrees. Same thing is true with these two inscribed angles. Since this inscribed angle intercepts arc RS, and this inscribed angle intercepts the same arc, we know that N has to be the same as this angle, so N equals 39. So not too difficult after all. For 28, we have an inscribed angle intercepting an arc of 56 degrees. Since the measure of an inscribed angle is 1/2 its intercepted arc, then C has to equal 28 degrees. All right, two fairly straightforward problems there. Let's go ahead and move on to problem 29. In problem 29, 30, and 31, we're looking for the value of x. In problem 29, this is an example of the angles outside a circle theorem. And that means that this angle is 1/2 the big minus the small. Well, we know what the big arc is. It's 250. And since the whole circle is 360 degrees, 360 minus 250 gives us 110. So we know the small arc is 110. We can go ahead and use that and put it in our formula. So 29, we have x equals 1/2 the measure of the big arc, 250, minus the measure of the small arc, 110. That gives us 1/2, 140, which is 70 degrees. For problem 30, this is an example of the angles inside a circle theorem. If two chords intersect inside a circle, then the measure of the angle formed is 1/2 the sum of its intercepted arcs. So it's intercepting these two arcs. Therefore, we can say x equals 1/2 152 plus 60. So that's what we're going to write for 30. X equals 1/2 152 plus 60, which is 1/2 212, which is 106. In problem 31, this is again an example of the angles outside the circle theorem. And here we have this angle is 1/2 the big minus the small. But here we have a variable for one of the arcs instead of a variable for the angle. So let's see how that works out. So for 31, we have 40 equals 1/2 96 minus x. So the algebra is just a little bit different here. Instead of distributing this 1/2, I'm just going to multiply both sides by 2 because this side is being divided by 2. So 80 equals 96 minus x. Now we can subtract 96 or we can swap sides. I don't like working with negatives, so I'm going to subtract the 80. 0 equals 16 minus x. X equals 16 because I added x to both sides. All right, let's move on to problem 32. In problem 32, we have a totally different theorem at work here, but it acts just like the inscribed angle theorem. This is the tangent and intersected chord theorem. And what it says is if a tangent and a chord intersect at one of the endpoints of the chord, then the angle formed is 1/2 the intercepted arc. So this angle is 1/2 this arc, which means that the arc is twice the angle. So if this angle is 120, then the measure of arc XYZ is going to have to be 240. So we know that the measure of XYZ equals 240. Now on to problem 33. In problem 33, we're using the segments of secants theorem. And what it says is that the length of the secant segment times its external segment equals the length of the other secant segment times its external segment. Let's go ahead and write that down and see if we can't come up with an equation that will let us solve this. The entire secant is 4 plus 6, so 10, times its external segment, 4, equals the entire secant segment, which is x plus 3, times its external segment, x. Now, to solve this, we have 40 equals x times x is x squared, x times 3 is 3x. Now we have a quadratic we're going to have to work with. So let's subtract 40 from both sides. And we have 0 equals x squared plus 3x minus 40. So in order to solve this quadratic, we can try to factor it. So let's break this apart. If it's a quadratic, it's made up of two linear factors, and this times this has to equal this. So to reproduce this term, I'm going to have an x and x. So when I multiply x times x, we have x squared. And since this sign is negative, I know that these signs are going to be opposite. So we're going to have a plus and a minus. Now what I need is factors of 40 that add up to 3. Well, the easiest way, for me anyway, to find the factors of 40 is I'm going to do prime factorization. So the first prime number is 2. 2 goes into 40 20 times. 2 goes into 20 10 times. 2 goes into 10 5 times. So those are my prime factors. Now, what products of these numbers give us the conditions necessary? Well, if we need a 3 over here, I can see that 2 times 2 times 2 is 8. 8 times 5 is 40, so that gives us two factors. And some combination of 8 and 5, 8 minus 5 is 3. So that should work. So if I put an 8 here and a 5 here, that should give me what I'm looking for. So let's try it. X times x is x squared. X times negative 5 is negative 5x plus 8x. 8 minus 5 is 3, so that reproduces that center term. 8 times negative 5 is negative 40. So these are my factors. Now, using the zero product rule, I know that if x plus 8 equals 0, then x equals negative 8. Now, what I meant by the zero product rule, if the product of two things equals 0, then one of those two things has to be 0. So if we assume that this is the one that equals 0, x plus 8 equals 0, so solve for x equals negative 8. Well, that can't possibly be the length of a segment because it's negative. So I can eliminate this one as a possibility. Now let's assume that this one is the one that's 0. X minus 5 equals 0. Therefore, x equals 5. So this is our answer. Let's move on to problem 34, and I'll do that in the next video. So I'll talk to you in the next part.